So today we're going to use Desmos or your graphing calculator or GeoGebra to talk about and learn about asymptotes. So remind me, what do you remember about asymptotes from last year? Yes, sir. It's a line where things do not touch, okay? With a little asterisk caveat here, okay? So it is a line that our graph is approaching but doesn't touch star, okay? Remember the doesn't touch star thing, and we're going to talk about that in a bit, okay? So when we first talked about asymptotes, that was the chapter on rational functions. And rational functions were of the form 1 over x. Okay, our book calls them reciprocal functions. And that was one of our parent functions that they wanted you to remember from last year. So last year, we did things, and I'm going to make this a little bit bigger. We did things like graphing 1 over x, and then we graphed things like 1 over x plus 2. And what did that do to it? Up 2. And then we did 1 over x minus 4. And what did that do? Right, 4. And we remember seeing those and working with those. And then we did a negative 1 over x. And it reflected it, right? Okay, so we did all of those kinds of things. Okay, so this time around, we want to see and be more formal about what's causing these asymptotes, these lines that we're approaching but not touching. Okay? So the first thing I want you to do is, if you are in Desmos, I want you to put in your 1 over x. On your graphing calculators, put in 1 over x. Okay? But on the Desmos, I would like you to also put in an extra line here, or 2. So we're going to put 1 over x here. And we get our function that we're expecting to see. Okay, I'm in projector mode. And then let's just do x equals 0 and y equals 0. And I'm going to change the color of the x equals 0 and the y equals 0. So I can click on the settings, and I want this to be maybe blue with a dashed dotted kind of thing. Red's probably okay, but I want it to be dashed or dotted. And maybe I don't want orange, because orange doesn't really stand out very well, so I'm going to choose purple for my original function. Okay. So, very short period of time, we've graphed y equals 1 over x. And we have these sliders in Desmos that allow us to move back and forth to try to see where those asymptotes happen to be. So I think that x equals 0 is a good asymptote that represents that line, right? Or that place that it's approaching and not touching. Same thing with the y equals 0. I kind of gave you a hint and started you off with the right ones. Okay? So when we go back to our sheet, and we want to know what are the asymptotes of f of x equals 1 over x, we're looking for the equations of those lines. Okay? So what was one of them? X equals 0. Okay? And I love that you said x equals 0 and not just plain old 0. 0 is a number. X equals 0 is a line. Okay? What's the other one? Y equals 0. So this is my vertical asymptote, and this is my horizontal. Nope, I am though, because I think it might help you remember them. It's kind of weird because our x-axis is normally horizontal, but a vertical asymptote is the line x equals 0. Okay? So 1 over 1 up. So next we want to talk about the domain. Okay? What is my domain for this function? Yes, Carissa. I love that you used our interval notation. Okay. Negative infinity to 0, 0 to positive infinity. Okay. We could also have just said real numbers such that x is not equal to 0 if you want to go with the older version. Older way, last year's way of saying domain. Okay? Because we can follow the x-axis and we get to be everything except right here where that asymptote lies. And then we get to be everything to the right of that asymptote. Okay? Range. Same as the x, because y equals 0 is our horizontal asymptote. So negative infinity to 0, 0 to infinity. All real numbers such that y can't be 0. What caused that vertical asymptote? Looking at the equation. Denominator can't be 0. So when x became 0, we had a problem. And that's what caused us to try to approach it but never touch it. Does that make sense? Okay. So graph the next one. When you graph the next one, make sure if you're in a graphing calculator that you're using, first of all, the negative sign, not the minus sign, and that you're putting a parentheses around the x minus 2. Otherwise, your calculator, because it knows order of operations, is going to say, I want to graph the opposite of 1 divided by x minus 2. And it's going to want to shift this guy just down 2. But we really want this to shift it right 2. Because of the 2 is with the x. Okay, so graph that one. So now we've got it graphed. Oh, I didn't. I should have. Sorry about that. So we've got this graphed. Okay, that's what it should look like. Do our asymptotes need to change? Yep. Which one needs to change? The x. So the blue one needs to change. It looks like it should be positive 2. Okay. So it's a good guide for us. Did the y asymptote need to change? Nope. Okay. So back to our other screen. Okay. Now we were approaching here, and actually at 2. If it helps you to draw those asymptotes, by all means do it. And it's going to look like this because of the reflection. Okay. So what was our vertical asymptote? X equals 2. Why? Because 2 makes a 0 in the denominator. Okay. X minus 2 can't be 0. So x equals 2 is my problem. It won't get necessarily, good question. I don't think it will give you a solver method to say that, but it will in the table get really close to a number. You'll start to see it converge on a number, and that's that number. Okay. And I can show you how to split your table too, or you split your screen so that you can see the graph and the table at the same time. Okay. All right. So x equals 2 is the vertical asymptote. What about the horizontal? Y equals 0 didn't change. Okay, domain. It approached 2 but couldn't touch it. And then on the other side of 2, it was able to go on to infinity. All right, what about range? If you want to write it in the old style form, all real numbers y not equal to 0, or the same thing that we had for our last one for the range. Okay? Yes, sir. Okay, and that could be because we didn't have it in parentheses. So notice that it's doing the x.
Well, I tried.
Okay, so let's do a insert. So when you want to insert, you go second, insert, and you insert a parentheses around it so it shifts everybody over so you don't have to retype. And then you close your parentheses. Now graph. There you go. Okay, and it's not connecting the dots, so it's not showing you those poles. But if we go to format, I don't think we can, I don't remember where we connected. Axes on, axes off. I can do a grid on. It might help. Not really. Okay. All right, that makes sense? All right, next one. Next one's going to be a little different. 4 over x squared plus 1. Everybody get something that looked like that? Especially when you put parentheses around the x squared plus 1 in your graphing calculator, so that the whole denominator is that. All right, so first question it's going to ask, I'm going to quickly sketch this. Looks something like this. Do I have a vertical asymptote this time? Why not? Awesome. No matter what we put in the denominator, a negative number squared is always positive, right? Positives plus 1 is always still going to be positive. There's never a chance that this is going to be 0 in the denominator. So we have no vertical asymptote. Does that make sense to everyone? Okay, that's what causes vertical asymptotes, denominator equal to 0. So we can eliminate that vertical asymptote for the moment by just saying, I don't want to see you anymore. Go away. Okay? What's my horizontal asymptote? Y equals 0 again. Okay? So what does that do to the domain? All real numbers. We don't have any restrictions, no asymptotes, right? No vertical asymptotes, so all real numbers. Or negative infinity to infinity if you're using interval notation. What about range? Okay, so we can we be 0? No, so curved bracket, right? And then what? Up to 4. And then close bracket, right? Because we don't get to be negative. It's not in the graph. And we don't get to be 0. We get really darn close to 0, right? And then how high do we get to be? 4, max of 4. Do you see that I will never ask you for range unless you've graphed it? Because there's no way for you to know it. We can tell what the domain is by checking out the function, but we can't really tell what the range is going to be unless we can picture it in our mind or draw it. Does that make sense? Mm-hmm. For the to show all reals for this one, we would say just negative infinity to a positive infinity. Oh, the other way. Okay, so the other way, if we wanted to write this the old style way, we would say that we can go from 0. So y has to be greater than 0 and less than or equal to 4. Okay, so or you could write it in one fell swoop. Y is between 0 and 4. So 0 less than y less than or equal to 4. All the same way to say the same thing. Different ways to say the same thing. All right, last one. Do we have a vertical asymptote here? Let's put that 2 on there again. Is 2 the right size? Two's not quite it, is it? Actually, good question. Which one am I talking about? Because it looks like we have 2 asymptotes here, don't we? Good. Let's make that one -2. Okay, we get 2 vertical asymptotes this time. What caused us to have 2 vertical asymptotes? Yeah, the squared. If we say x squared minus 1 is equal to 0, that makes x squared equal to a positive 1 when it comes to the other side, right? And when we take the square root of both sides, we have to remember to introduce our plus or minus, because positive or negative 1 would make that a 0. And let's see, we get 2. Okay. What about horizontal asymptote? Same. It's got boring, isn't it? Hasn't moved. Okay. So y equals 0 is our horizontal asymptote. I always want to draw this the wrong way. It's going to go top. Okay. Did I do that wrong? Just raising your hands. I flipped it. I always want to flip it. I did. It should go this way. It's a different kind of eraser when it comes into this version. So I want to be up high, right? And I flipped that one too. I initially had it right in my brain and it flipped on me. There we go. Okay. Yes. Mm-hmm. Great observation. Let's check and see. Is it actually going through 0? Because we were talking about it not being able to do that, right? And look, 0, 0 is a solution. Okay? That was that little asterisk. I said, remember this. Okay? It's not supposed to go through asymptotes, is it? Okay? But here it did. Okay, which asymptote did it go through, vertical or horizontal? Horizontal. Okay, so it's okay to cross or go through a horizontal asymptote every once in a while, but never verticals. Okay, verticals is completely undefined, not happening, but it can sometimes cross through a horizontal asymptote, provided its end behaviors are approaching that asymptote. So notice it's approaching 0 as it's heading to the right. And it's approaching 0 as it's heading to the left, isn't it? So it's okay that it did this little jog and touched right there, provided it's a horizontal asymptote, never vertical. Okay? There's always an exception to the rule. Question. Great question. When you're on a graphing calculator, if you're in connected mode, it will show, it'll draw this graph and it will show it going down to negative infinity, and then it will trace the line back up if you're in connected mode, and then show it going like so, and trace it back up, and then show it going like so. And that is the asymptotes themselves are not part of the graph, it's just the way the calculator is set to draw it. Okay? So these are not supposed to be, the asymptotes are not supposed to be part of the solution to that graph. Question? Okay, did you put it in parentheses?
I did, and then I also did.
Yeah, so make sure you put it in parentheses, and then you may need to zoom in on it, because I think you're zoomed out quite a bit. So insert your parentheses. So second, insert. There you go, there you go. Let's put our you don't have your divide sign. Y equals. We need X, insert. So insert. Right here, and then hit your divide sign. There you go. Now try and graph. Okay, now let's zoom in. So when we go zoom, let's press 2, and then press enter, and it's going to zoom in on you. And we're still quite a ways out, but yeah, I believe that it should be showing you that. It may not be graphing quite right. We'll check on it. Okay. All right. Does that make sense for most of you? Okay. So domain. Let's not do this one in interval notation because it's going to be a lot of writing, isn't it? So good. We don't have a lot of space to write that, do we? If you wrote it in interval, you're fine. But we can anticipate that's going to be a problem because there's not a lot of space there. Okay, what about range? I would agree with most of that. Negative infinity to 0, 0 to infinity. But did it get to actually be 0, 0? It did, didn't it? If we put in 0 here, 1 or 0 divided by 0 minus 1, we're not breaking any laws. We're taking 0 divided by negative 1, we get 0. So our actual range is going to be all reals. Okay, negative infinity to infinity. Make sense? All right, so burning question here. What causes a function to have one or more vertical asymptotes? What made the verticals? The 0 in the denominator, okay? Whenever the denominator equals 0, we have a 0, an asymptote, a vertical asymptote. Okay? Now, what do you notice about the degrees of the numerator and the denominator of each of the rational functions? What's the degree of the denominator of this one? X to the first, okay? And this is like an x to the 0, right? Because anything to the 0 power is 1, okay? So we have a 0 over 1 for our powers. What do we have here? 0 over 1 for our degrees. What about this one? 0 over 2, and this one? 1 over 2. Okay, in each case, where was the bigger degree? The denominator, okay? So the denominator had a higher degree than the numerator. Okay. Then the last question on here, I go too far, says, in terms of the horizontal asymptotes, what did every one of those have in common? Y was 0. Didn't matter what we did, Y was always 0. We never got to move that guy, did we? Okay? So your job is to finish this tonight. Okay? Have it ready for tomorrow. Yeah,